Hello, everyone. I'm Lucas Campos, and today we'll be discussing Physics 2211 Lab 4 Oscillations. And moving into our agenda for today, we're going to start off with the introduction and the purpose of the lab, and then move into fundamental principles, and then the tracker, the glow script code, and then discuss possible errors, and then finish with the discussion questions. All right, introduction to the lab. In this lab, we experimented with an oscillation system with a spring and mass, and then we put that data in a tracker and then calculated data, and then use GlowScript to compare the actual tracker data versus computed models. So the fundamental principles used for this lab, it's mainly the energy principles. We have K equals 1/2 mv squared. We have the potential of a spring, 1/2 Ks squared, the gravitational potential, NGH, and then our other formulas like R final equals R initial plus V times delta T, and then the velocity update formula. All right, and here's a screenshot of the tracker application used. So the video was put in here, and then you can see the graphs on the side that from the data in the video, and then from this data we exported it and then put into an Excel sheet and then export that Excel sheet to then be used in glow scripts. And so, like I said, using that data, we put in the glow scripts and then, well, first in glow script, we changed the mass of the system and then the position velocity. And then down here, we changed the delta T. And this is just to slow it down and like make it so it's a little bit more accurate. And then moving over here, we changed G to 9.8, and then we have the spring constant and the relaxed length of the spring. And then here is just some formulas to find length of the spring and whatnot. And then down here we have the K potential energy of the spring, potential energy of gravity, and then just total energy. It's just formulas from the class. So part 2 of GlowScript code, we found the gravitational force, not then the spring force, and then the net force, which is the spring force plus gravitational force. And then we here have the length of the spring and then the energies. It's similar to the last slide. Just finding the energies here. And then here's a picture of what the glow script made with the spring moving around with the mass at the end of it. In our glow script graphs, we see here the energy. This is concentration of energy just shown in a graph. So as one goes up, one goes down, it's balanced, it works off each other. And then here we have compared of the model and the experiment of an X position and Y position. And you can see that they're really very similar, but one doesn't account for drag. The model form does not account for drag, so that's kind of something that can show some off balance there, but overall it's the same shape, it's almost the same thing. So possible errors to the lab, the tracker application, sometimes it's not very accurate in measuring the data points. It's all just rough estimates. And then we have the glow script. So the computed, like I just said, doesn't count for outside factors like drag. And yeah. So moving into further questions. First question, yes, energy principle was satisfied because total energy is conserved and only converted into different types of energy. So like here, our system is the spring, the mass, and Earth, and the change in energy is always equal to 0. And then the second question, I found that the period of oscillation in the x direction was approximately 1.15 seconds, and the period of oscillation in the y direction was approximately 0.9 seconds, and this is different due to the force of gravity. Thank you. That wraps up our lab.